Okay, welcome back to Bombala Math. So in this lesson, we're going to do solving linear equations with a variable on one side. I'll do another lesson solving linear equations with variables on both sides, but I just like to separate it because it's definitely a different skill set. So looking at what we have here, the four problems, you can tell that the difficulty level is increasing. And of course, when we get to here, this is when my students always say, Mr. Bombala, why do you hate us? Because I put a fraction in there. And of course, you can't avoid fractions because it's just a part of math. So we're going to have to learn to work with them. That's why I have that problem in here. So we'll start with number one, which is just a two-step problem, which means I'm just going to need two steps to solve for x. So we're doing with solving for x, we want to isolate the x, get it by itself so that we can solve that problem. Basically find out what value of x will make this equation true. So in order to do that, I need to do inverse operations, and I want to get rid of my pluses and minuses first. I want to do that first before I get rid of any multiplication or division. So I have a minus 9 here, so the inverse of that would be a plus. So I'm going to add 9 to both sides. So by doing that, that becomes 0, which is what I want, and then this right here becomes 20. Now what I also tell my students to do is draw a line where the equal sign is straight down. Create that wall from one side of the equation to the other. This way you know you're moving something from one side and moving it over to the other side. So that would give me 2x is equal to 20. A lot of times students their work is disorganized and they'll wind up moving something, especially when there are more terms on one side, they'll literally move something to the same side and then go ahead and keep solving it out. Of course, that's not true. You can't do that. You have to move it from one side to the other. But it's because the work is not organized that happens. So again, I just encourage them to draw that little wall that goes with the equal sign so you know which side, where's the left and where's the right side, and what you're doing with your operations. So now here, I'm going to divide by 2 because this is 2x, which is multiplication. So I'm going to divide by 2 to both sides, and then that becomes 1x is equal to, and 20 divided by 2 is 10. And of course, you can always check your answer by plugging it into the original and making sure the left side is equal to the right side. So if I plugged in 10 here, 2 times 10 is 20, minus 9 is 11, 11 is equal to 11, so I know it is correct. Looking at number 2, again, we have a little bit more going on here. We have this term in front with the parentheses, so typically we do distributive property. We may be able to avoid that depending on the problem. And then we have the minus 8. So I want to get rid of the minus 8 first, and in order to do that, I'm going to add 8 to both sides. I'm going to go ahead and draw my line here so that I have my wall, make sure that I'm moving something from the left side to the right side. So I'm going to add 8. So that's going to go away. And then I have 4 times 3x plus 1 is equal to 20. Now this is when you have an option. You could go ahead and distribute this 4 to the 3x plus 1 and still continue to solve the problem. Or, because this is multiplication, you can divide both sides by 4 and get rid of it. I would only encourage doing that if this number will divide into this number evenly. If it doesn't, you're going to create a fraction, and we don't want to do that if we don't have to. But 4 does go into 20, so we can go ahead and do that. So I'm going to divide by 4. So that's going to reduce, and I have 3x plus 1 is equal to 20 divided by 4 is 5. Now I'm down to a two-step, just like I was right over here. So I'm going to do the inverse, so I'm going to subtract 1. So 3x is equal to 4. And then, of course, do the inverse, so I'm going to divide by 3. So x is equal to 4/3. Now, if you would have distributed here and then solved the problem, you would wind up with the same answer. It would work as well, as long as what you did is correct. So I like to try to simplify as much as possible. This, I could tell if I divided, it was going to divide evenly, so I went ahead and did that. Sometimes it makes it a lot easier. All right, so now to number 3, everybody's favorite problem, because it has a fraction. You can get rid of the fraction and work with this problem if you know what to do. So looking at this, I have a denominator of 5. Well, if I multiply this side and this side, if I multiply it by 5, what's going to happen is 5 times 3/5, that's going to reduce, and I'll get rid of the denominator. And I won't have a fraction anymore, which makes the problem easier. Or you can just go ahead and work it from here, add the 6 over, and then work with the fractions. It doesn't matter. A lot of students these days are using calculators, so this is going to do the work on the calculator. You should be able to do it by hand, and I will have a lesson on fractions and working with decimals and all that stuff. You should be able to do it by hand, but a lot of students are using the calculator to do it. I'm going to go ahead and get rid of the 5. I think it's easier. So I'm going to multiply both sides. Right. Multiply both sides of the equation by 5. So if I do that, 5 times 3/5, that's going to go away here, and it's just going to leave me with 3x, because 5 times 3/5 will be 3. And then 5 times minus 6 is minus 30, equals 5 times 3 is 15. So again, you're just pretty much distributing this to all of the terms in the equation, because you can't just multiply 5 on this side. You have to do it to the whole equation to preserve the equality. Now I'm down to a 2-step, so I can just do the inverse. I'm going to add 30. So that gives me 3x is equal to 45. Then I'm going to do the inverse, so I'm going to divide by 3. So x is equal to 15. And again, if you were to plug this in here, you would see that the left side is equal to the right side. Now, if you wanted to work with the fraction, or you didn't pick up on the fact that you could multiply both sides by 5 to get rid of it, I'll just do it right over here real quick. So we have 3/5 x minus 6 is equal to 3. So again, you would get rid of the 6 first. So I'm going to add, do the inverse. I'm going to add 6. Of course, don't forget your little line near your wall, so you don't forget that. So then that's going to go away, and you have 3/5 x is equal to 9. So because this is a multiplication, most students are going to divide by 3/5 because they're using a calculator. Well, dividing by a fraction, you're basically multiplying by the reciprocal. So it's just easy to go ahead and do that right now. If I want to get rid of 3/5, if I just multiply by the reciprocal, when you multiply reciprocals, you're just going to get 1. So just do it to both sides. I'll put that over 1. So this becomes 15 over 15, which is just 1. So x is equal to, multiply this, you get 45 over 3, which is equal to 15. Of course, we get the same answer. So it's up to you. I gave you both options. I just like to get rid of fractions. A lot of times it just makes the problem go a lot faster if you can do that. All right, and the last one. So you want to be careful here. I picked this problem because students always make this mistake. They see this, and it's so tempting to say, oh, 7 minus 2 is 5. You can't do that based on the laws of operations. You can't, order of operations, you can't do that. You got to get rid of this 7 first before you can do anything over here. Now, technically, you could distribute this minus 2 if you wanted to, but you cannot combine these and say that that's 5, and students do that all the time. So I'm going to draw my little wall here and do my inverse operation. I'm going to subtract 7. Remember, this is a plus 7. If I want to move it over, I got to do the opposite, which is a minus 7. It's got to be 0. That goes. Make sure you keep the sign with the 2. This negative is with the 2 here. So it's minus 2 times 4x minus 1 is equal to 11. Now, remember what I said in this problem number 2. If you can divide and it works out evenly, go ahead and do it. If it doesn't, you probably don't want to do it. Well, I'm going to look here. If I divide by negative 2, 2 doesn't go into 11. So that's not going to work. I'm going to get a fraction. And I don't want to work with fractions if I don't have to. So I'm just going to go and distribute this. So that gives me negative 8x plus 2 is equal to 11. I don't have any fractions right now. It's good. Back to a 2-step. So the inverse, I'm going to subtract 2. Minus 8x is equal to, and this is 9. And you can probably see right here, we're going to wind up with a fraction, but that's okay because that's our final answer. So I'm going to do the inverse. I'm going to divide by negative 8. So x is equal to negative 9 over 8 And again, if you plug this in here, make sure that the left side equals the right side, and you'll see that that is true. All right, so hopefully you enjoyed this lesson, and you can see my other lessons on Mambala Math on my YouTube channel. And like my first period used to say, make smart choices. See you next time.